In an experiment using a photocell, ultraviolet light of varying frequency but constant intensity is made to strike a metal surface. The maximum kinetic energy of photoelectrons for each frequency f is measured. The graph below shows how the maximum kinetic energy varies with the frequency. State, okay, write down one precaution that should be taken when conducting this experiment. That is 10.1. So ultraviolet light should not be in contact with the skin for prolonged periods of time, and it shouldn't get into the eyes either. So we can say use protection, such as goggles to prevent UV light from entering the eyes. Entering the eyes. 10.2. State one factor which determines the kinetic energy of photoelectrons emitted by a metal surface. Let's look at this formula. So we want to know what influences the EK max. So think about it. It will be the work function of the metal, the work function or the energy of the photons. So any of these two. 10.3. Use the graph to determine the value of the work function. 10.3.2, the EK max marked X. So let's start with 10.3.1, the work function. So the work function is defined as the minimum energy that is required in order for electrons to be ejected from a metal surface. It means that when the energy that is supplied by the photons is less than the work function, you will not have any kinetic energy. So from this point, when the frequency is 1, when the frequency is 1 to the right of the graph, that's where we will have some kinetic energy, which means from 1 to the right, that's when the electrons will begin to move. That can only mean that 1.0 is the threshold frequency. The work function should be equals to HFO. So this is 6.63 times 10 to the exponent of negative 34. And then we are going to use 1.0 times 10 to the exponent of 15, because the unit is times 10 to the exponent of 15 there. This is 6.63. Negative 34 multiplied by 1.0 times 10 to the exponent of 15. So I'm getting 6.63 times 10 to the negative 19 joules. 10.3.2. So now we need to use the graph to find the kinetic energy at X. So there's a couple of ways to get the answer. Let's look at each. So we know that energy should be equals to the work function plus EK max. So the work function of the metal won't change because we are using the same metal. The only thing that we are changing is the frequency of the light. So the work function will remain as 6.63 times 10 to the exponent of negative 19. That's our work function. Energy is given by H multiplied by the frequency. We know that H is 6.63 times 10 negative 34. And then the frequency. So when X is 2, when the kinetic energy is X, the frequency is 2. Because we can see that when the EK is X, the frequency should be equals to 2. So this is 2 multiplied by 10 to the exponent of 15 plus X. So this is 6.63 times 10 negative 34, 2 times 10 to the exponent of 15 minus 6.63 times 10 negative 19. So I'm getting 6.63 times 10 negative 19 joules. That is the EK max at X. This is option 1. Let's look at option 2. So E is equals to WO plus EK max. But EK max is on the y-axis. So this is going to be E minus WO. E is given as H multiplied by the frequency minus WO. So this gives the equation of a straight line. Notice how the gradient is Planck's constant. X is F because F is on the x-axis, meaning that C will be the work function. Okay, so the gradient should be equals to the change in y, which is EK max, all over the change in frequency. The gradient is Planck's constant. So this is 6.63 times 10 to the exponent of negative 34. So we will use X. But we've already established that when EK max is X, the frequency should be 2 minus. So we'll choose any other point. We'll just choose 2.7 because that's what we are given. So 2.7, and then the frequency should be 1.5. And then the units here, it's times 10 to the exponent of negative 19. And then the units at the bottom, it's times 10 to the exponent of 50. So here I'm getting 3.315 times 10 negative 19 equals to this will take care of that. Therefore, X should be equals to plus 2.7. So I'm getting 6.015, 6.02. But notice the units there, it's times 10 to the exponent of negative 19. So this will be times 10 to the exponent of negative 19 joules. Moving on, light of frequency. So the frequency of light is given as 5.5 times 10 to the exponent of 14 hertz, is made to strike a surface whose work function is given by, so the work function is 4.0 times 10 negative 19 joules. Define in words the term work function of a metal. So the work function is defined as the minimum energy that is required in order to remove electrons from a metal surface. Show by means of an appropriate calculation that photoelectric effect will not take place. The only way that the photoelectron effect does not take place is if the energy that is supplied by the light is less than the work function. Because if the work function is defined as the minimum energy that is required in order to move an electron, it means that the energy that is supplied by your light should be greater than the work function in order for us to see the photoelectric effect. If E is less than the work function, then there's no photoelectric effect. So E is given as HF. And the frequency is given as 5.5 times 10 to the exponent of 14. 6.63 times 10 negative 34, 5.5 times 10 to the exponent of 14. So I'm getting 3.65 times 10 negative 19. So notice how the energy that we have calculated here is less than the work function. So the energy, this energy right here, is less than the work function. So no photoelectric effect.